In this video, we are going to prove the trig identity cosecant 2x plus cotangent 2x equals cotangent x. Well, what we want to do is we want to convert each of these secondary trig functions to primary trig functions. So we'll let cosecant 2x be 1 over sine 2x and let cotangent 2x be cos 2x over sine 2x. And then in doing that on the left side, we have a common denominator readily available to us. So we can just add the numerators and we'll get this expression right here. On the right-hand side, it's a little simpler. Cotangent x is simply cos x over sine x. Now at this point, it's important to recognize that we have angles of 2x on the left and we have angles of x on the right. So we've got everything in terms of cos and sine, but we've literally got different angles themselves. We need to fix that. And the way we're going to fix it is by using the double angle formulas. Now there's only one double angle formula for sine, so we already know sine 2x will be 2 sine x cos x. But for cos 2x, there's three different formulas we can use. Well, our strategy is going to be to let cos 2x in that numerator right there, we're going to let that cos 2x be equal to 2 cos squared x minus 1. And the reason we're going to do that is that this 1 and this negative 1 are then going to eliminate each other, and we won't have a constant term anymore on the left, which is good because we don't have a constant term on the right, and we're trying to get them to equal each other. Okay? So like it says here, use our double angle formulas to get rid of the angle 2x. Recall that we have options regarding which of the formulas for cos 2x we can use. Thinking logically, we'll say cos 2x equals 2 cos squared x minus 1. The reason we should do this is that we're adding 1 to that, so by using the version of cos 2x that involves negative 1, we get rid of the 1's and there's no constant term. But if we don't think of that, it'll still work out, but it'll just take some extra steps. So we let cos 2x equal 2 cos squared x minus 1. Our 1's cancel out, and we are left with 2 cos squared x over 2 sine x cos x. And at this point, to be honest with you, you could just cross out those 2's. And since you're left with cos squared x over sine x cos x, you could just say, if you wanted, that that equals cos x over sine x. Here I was, a little bit more verbose, and I just sort of showed that 2 cos squared x is technically 2 times cos x, and that 2 sine x cos x is technically 2 times sine x times cos x. And I sort of spelled it out in the lesson a little bit more just to make it clear what was happening. We end up with cos x over sine x in the left, and that's what we have on the right. And that means we've shown the thing we wanted to, and we can write quod erat demonstrandum.